Hello, we're going to look at an example of a programming technique called sequential function charts. And this is a method that's very useful when your program tends to be sequential in nature, where one thing is executed and then another and so on. So very, very useful for this method. So we're going to start off by using a very simple program which only has 2 steps and a couple of transitions and 2 actions. And we're going to use the HMI that's on the left-hand side. So a sequential function chart, or SFC, is made up of 3 parts: steps, transitions, and actions. And each step will have an action, and the action continues to take place until the transition becomes true. Then it moves to the next action. And the actions are kind of what you want to have happen during that step. Now the steps also have something called properties, and I'll open up the properties box. It's the box with the 3 dots. And what we'll typically want to do in the step is set up a timer preset and a counter. So this step would have a preset of 2000. We may or may not use that timer, and a count equal to 0. Now, every time we go into a step, the timer begins and the counter increments by 1. Okay, that's important to note when you're working with the program. And during each step, we're going to perform a certain action. So in step 1, we're going to do this action. In step 2, we're going to do this action. And inside the step box, as I said, are the properties, but it also indicates which is the initial step. And the initial step is the one that executes as soon as the program starts. And there's only one initial step. So in my case, step 1 is the initial step, and it's kind of identified by having a rectangle with 2 outlines. All of the other steps only have 1. So let's download this program. I have downloaded the program, and one of the first things that you notice is that the top bar and the left bar turn green. That's an indication that the program is running. And also the step that's currently being executed is highlighted in green as well. And the action that's being executed is highlighted here in green also. So we're on the first step, and the action here is to make the step count of step 1 equal to 0. Have the return solenoid equal to 1, and that's over here. It's turned blue to indicate that it's true, and the done and the ready light are equal to 0. Now you don't see them because there's a spot here reserved for them, but they're both off. So it's sitting, executing that step, waiting for this action to go true. So it just kind of stays in this loop waiting for this to go true. And what we are waiting for is the start button to be active. And if I hover my mouse over start, it should tell me the current state. And sometimes that can be a little bit tricky, but there we go. So the tag is a Boolean. The value of that tag is 0. Okay, so I'm waiting for that to change. And when it does, it will move to the next step. It hasn't yet, but when it does, it'll move to the next step. And that step is programmed with a 1-second delay. So it'll stay on that step for 1 second, and when that's done, it's looking for the step 2 being done. When that timer is complete, it will come to a stop. And during that step, it'll turn the ready light on, and it'll de-energize both of the solenoids, the retract and the extend. So let's see that happen. So I have to press the start. Okay, it will move then to step number 2, wait 1 second, and then come to an end. So keep an eye on this stop icon. I just pressed it, 1 second, comes to an end, and both solenoids are off. So that's the very basics of working with sequential function charts. This is part 1, but I'm going to add to it. In this next example, we're going to look at the differences between a stored action and a non-stored action. And we have 2 in this example. This top action is non-stored, and this bottom action is stored. The main difference between the 2 is that this non-stored action only executes while on the step, whereas the stored action will continue to execute all of the time, continuously, even when it's off that step, even when it comes to a stop at the very end, it'll continue to execute. When we go offline, then it will stop executing. So let's see how this happens. I also have a couple of values here. The step 001 and step 2 are being indicated on the screen. The program is waiting for the start to be pressed. I'll do that right now. And now that the start is pressed, we're into the second step, but we're still executing this action, no longer this one. So whenever I press the start, it's going to display the ready. And even once this step is done, you'll see that we come to a stop here. Okay, we are stopped now, but this action is still executing. So I can press start and it continues to do that. So the way that I set this up is I'm going to go offline. Okay, if I want to change the action, I click on this little square. And there's actually a pull down window that will appear. And you have a choice of stored, non-stored, and there are a few others. One that we use a lot is P1. So the three primary ones we'll use here are non-stored, that's the default, the stored, and the P1, which is, it'll execute that step as soon as it comes into that step. Now the reset action can kind of override a stored action. And if you want to stop executing that stored action, you have to execute the stored action, you have to execute a reset. And we'll show you this as an example later on. So I hope this helps in understanding the difference between stored and non-stored. Hello, this is the third part of the demonstration for sequential function charts. And some of the things that I want to demo in this section are selection branches, the P1 qualifier, branch priority as well. So we'll look at all of those things. And we'll start off with the P1 qualifier, which is right here. If I click on this, it'll show you all of the qualifiers. Okay, and we've used the stored and non-stored, but we're looking at the P1 qualifier right now. What this does is that when you come into this step, it will execute this action, but only once when you come into the step, whereas a non-stored action executes it the entire time it's on the step, and a stored action executes all of the time. So that's the difference between the three. This one, only one time when it comes into this step. This is very useful for initializing variables, doing something just one time and not continuously during that step. The second thing to look at is something called a selection branch. And this right here, all of this together is a selection branch. And what happens in a selection branch is that once it leaves, in this case, step number 4, it will look at the two possible transitions here. And in this case, it's going to test this transition first. If it passes, it will go to step 6. If it doesn't, it will come to number 2. Check this, and if it passes, it will go to step 9. If it doesn't pass either of those transition tests, it will stay at step number 4, okay, until one of those steps becomes true. If it's less than 18 for the temperature, then it will go to step 6, and within step 6, I can open this up and show you that there's a 8,000 millisecond or 8-second delay, and it will cause this action to take place where it makes power equal to 250. But if this one is not true, it will come over to here. If it's greater than 22, it will delay there for 12 seconds, okay, with this step 009.done, but it'll make the power equal to 750. And then it will come down here, okay? And what this is doing is this is just making a test to see if this step is done. If it came down this path, it's checking to see if this step is done. Now, how do you create a selection branch? Well, there is an icon up here that's called a selection branch diverge, and it always starts off with two transitions. You must have a step, and it must end with a transition. Once you want to converge or bring together the two transitions, you click on the first, you press Control and click on the second, and then you'll have the ability to select what's called a branch. I think if I hover it here, it's converge SFC elements. But it'll only happen when I create it from new, and I already have this one created. But you must converge them together. When you do this selection branch, one of the things that you may want to change is called the selection priority. Do you want the one on the right to be done first or the one on the left to be done first? And the way that you change that is you click on the wire till it's highlighted like this, right click, and then set sequence priorities. Now you can use the default or you can change them, and this allows you to move it up or down. So if you move it up or down, you'll notice that it tests this one first. If that one fails, it'll come over and test this one. So you have the choice of going one way or the other. And one of the other things I should mention is that as you are writing the code, you want to always make sure, and you can see that that is the case in this program here, that you're going step, transition, step, transition, step, transition. If you don't do that, you will see that you get an error. Even when you're coming into this selection branch, it's step, transition, step, transition. So you have to follow that step transition. If you try to connect a transition to a transition or a step to a step, it won't allow you, and that will create an error. So be careful of that. And again, we're using a P1. This performs that action, but only one time, just one time, and then it either waits in this action for that step to complete, or it moves on once the start button is pressed. So let's actually see this working. And so I'm going to start off with downloading the program. I've downloaded the program now, and you can see that on my HMI, the count is 0, step timers are equal to 0, and this one time during that one P1 action, and that's why you see there is no green indicator, it made the temperature equal to 20, the power equal to 500, which you see over here, and my step count at 0 is equal to 0. Okay, but actually here I'm displaying my step count on 4, which is currently equal to 0. So let's see what happens as I execute through this program. I'm going to scroll down a little bit. And when I press the start button, one of the things that you're going to notice is that in this step, I set the temperature to 20. Okay, I can change it, and I can manually change it on the HMI. But it does this test, and it's not going to pass this because it's not less than 18, and it's not going to pass this because it's not greater than 22, obviously. And when it does pass this or this branch, it will modify the value of the power. Okay, and then it comes in here, it stays for 8 seconds and 12 seconds. So let's have a look at that happening. So I'm going to move down here so you see these steps, but it's going to wait until I've pressed this start button. Okay, I've pressed the start button, and now it's at step number 4. But it's staying at step number 4. There is no action there, but it's waiting there because it's not passing the temperature is less than 18 because it's 20, and it's not greater than 22. So let's say I want it to come down this branch here. What I'm going to do is modify, because I've set up my HMI to be able to do that. I'm going to modify the temperature so it's greater than 22. So I'm going to come here and type in 23, hit enter, and now it is greater than 22. It comes down this branch, and you can see it's going through this timer of 12 seconds. And then after that 12 seconds, it's going to set the power back to 0. It's going to cause the done light to be on, the ready light to be off. And then this tells it to go back to step 0, right back to the top. And you see it's step 0. And what you can do is sometimes when you want to go to the top of the program by bringing a wire to the top, it's not very neat the way it connects the wires. So you can actually click on the wire and say hide wire. I may do that in a demo later on. So now we're back up here. Let's say I change the temperature to 15. It should go down the other branch this time. So I'm going to wait to press start. I press start, and it goes down this branch. It sets the power to 250. It's waiting 8 seconds. You can see that here. Then it's going to come down to this step, and it's going to wait 10 seconds while making the done light equal to a true. Eventually that will finish, and it is. Now we're back up to the start with the ready light on. And we're back to 20 degrees and 500 for power. and I can change that value to whatever I would like it to be. Okay, that's the end of the third demo.